Assalamualaikum and hi everyone. My name is Muhammad Abdul Rashid bin Adnan. I'm here to speak about design for manufacture and assembly subtopic, which is design for machining. Maybe there is so many questions in your head right now. Maybe you keep asking how machine and DFMA is related. So it's good here. I'm here to explain about it. Before that, I want to thanks to you for want to watch my public speaking video, and I hope this video can bring benefit to you. So let's go and let's start it. Before we start the main topic, we back to the basic to remind, or maybe someone who doesn't know what is a DFMA. So I will explain about it first. So DFMA is a short term for design of manufacture and assemble. DFMA is a combination of two methods, which is design for manufacturing and another one is design for assemble. Design for manufacture is the design for ease of manufacturing of the parts that will form a product. Easy to explain is breaking the part. Example that I can give is the process to make the body part of the pen. So to make the part of body, so we have to consider about the process, the material, the size, the surface of finish of the part. So that is a work for design for manufacture. Next, about design for assembly. Design for assembly is a tool used to select the most effective cost material and process to be used in the production in the early stage of product design. The aim of the DFMA is to reduce manufacturing and assembly costs and quantify improvement. Example improvement that we can say is to reduce the production time. The less production time, the more produce a product in a day. That will benefit to the factory or the company. So, another one is the FMA is also used as a benchmarking tool to review product competitors and as a tool to aid in cost negotiation suppliers. If you want to know, the FMA consists of 4 steps. The first step is about conceptualization. The second is analysis. The third is redesign. And the last part is conclusions. That's the 4 steps in the DFMA. So now, I will explain about the advantage if you using the DFMA. So the first advantage is about the speed. So the speed making the product or designed so that it can be increased because of the DFMA is the method that make easier for us to make the improvement. So that's the advantage from DFMA about speed. So now I will explain about the second advantage. The second advantage is DFMA can lower assembly costs. Why it can lower? Because DFMA can state what method that we want to use to assemble our products from the lower cost to the higher cost. So we will manage our product costing. So the third advantage is about higher quality and sustainability. The quality of the product can be higher by the improvement that made from DFMA. The DFMA method can detect which part is defect or can be improved so that the product can be in higher quality. So then I will explain about the fourth advantage. The fourth advantage is shorter assembly time. Production time can be decreased if we use the DFMA, and also it will be increased when we use DFMA. So that's ours to decide which one we want to use. So if we decrease our production time, it will affect at our company. So it will give the benefit to our company because we can produce more product in a day. The third advantage is about high quality and sustainability. The quality of the product can be higher by the improvement that made from the DFMA. DFMA method can detect which part is defect or maybe that we can improve so that product can be in higher quality. That's the third advantage. Then I will explain about the fourth advantage. Fourth advantage is about short assembly time. Production times is important at the company. If we use the DFMA, we can increase it or we can decrease it. Usually, the company is always want to decrease it because it can produce more product in a day. That's the explain about the fourth advantage. The fifth advantage is about the increased reliability, and the last advantage of the DFMA is about the safety. So that's all about the advantage of DFMA. Here's the example of article that prove DFMA method is good. So I have stated 2 articles. So the first article is about the redesigning of agar wood extracting machine applying the DFMA principle. This article was made by MS Salim at 2019. So this article is focused on cost. They get reduced cost of manufacture to increase the profits. So that's the first article. So it in fact good by using the DFMA method. So the second article is about the product simplification design improvement by using the DFMA method. This article is made from the Tan Di Yan at the UMP, University of Malaysia Pahang, at June 2012. So this article is aimed for reduced cost for labor. It's like the method that has been using by the Ford Motor Company. If you have heard about it, Ford Motor Company has saved $1 billion by using the DFMA method. So the result of this article, they get the efficiency of the product increase from 26.62% to 41.26%. The labor cost also reduced to RM 0.19. That's all from basic of the DFMA. Now, I will explain and talk about the DFMA for machine. So, what is machine? A machine is a mechanical structure that uses power to apply force and control movement to perform an intended action. Example that I can state here is about the lathe machine, CNC machine, milling machine, drilling machine, and others. At the house or rent house that you have stayed, is blend. It's also a one of the machine. Now, what is designed for machinability? Design for machinability is a design of part or product which is considered the ease with which part or product can be machined. So, in the DFMA, there is sequence of analysis. The first sequence is concept design. Then we move to the second sequence. Second sequence is about design for assembly. After that, the third sequence is design for manufacturing. And the last sequence is detail design. So, which one is machining is related with DFMA? So, of course, it's the second and third sequence. Design for assembly and also design for manufacturing, respectively. After that, there is 5 guidelines designed for machinability. The first guideline is about standardization. Standardization is about, for example, we use screw or bolt and nut that have standardized all country. For the second is about the choice of work material. So the work material that we have to choose is related with the product that we want to use. For example, if we want to use a cup, we can use a plastic material, we can use the stainless steel material. So that's the work material that we have to choose. And the third guidelines is about the size and shape of work material. So what size we want to make? If large, we have to use the large machine. And what shape we want to make? If the sharp shape, we cannot use the drilling. We have to use the laser or maybe CNC. So that's the third guideline. The fourth guideline is about assembly. What process they want to use for assembly? For example, welding, like I said before, bolt and nut, and another method. And the last guideline is about accuracy and surface finish. This is the guideline of the design for machinability. That is about selection of workpiece. So we'll explain about it. So selection the best type of the raw material workpiece as the first step in applying DFMA. And because it will depends on many 49 factors that affect their choice. For example, mechanical and chemical properties of the material, selection of the standard workpiece, or application of new net production technology. It's about the selection machining process. So at determining the most appropriate machine process and system should be taken into consideration. So the first consideration that we have to make is type of production. So what type of product we want to make? The second consideration is about type and shape of workpiece. What shape we want to make? Is it a sharp shape? Is it a round shape? Is it a rectangle shape? So that's depend of what we want to make. Because if we not consider about the shape, it will make the machine broke or something else can happen. So the third consideration is about the economically tolerance of product. Then the fourth consideration is about opportunities machining system. And the last consideration that we can state here is about appropriate tools and supplies. Now, I want to explain about assembly of the product. During assembly of product, provide the greatest possibility of applying DFMA method. Proper use of DFMA principle allows produce a high quality products. These principles are based on reducing the number of parts in assembly, implementation of symmetric part when product design allows it, easy design of products, ensure self-fixturing, and avoid parts that can tangle. So now, I will explain about design features to facilitate. There is the three of facilitate: drill, QAs, and milling cutters. I will explain one by one so that you can understand with the explanation about the design features to facilitate. So the first design features to facilitate is about drills. So there are six about drills. The first one is about the drill should be always perpendicular to the drilling surface, because it can avoid the starting problems and also helps in ensuring the proper location of the hole. Second, about the drills is about avoid interrupted cut when straightness of hole is important. It is advised to use a guide bush at each re-entry surface. The center point of the drill must remain in the workpiece throughout the cut. The third one is about a minimum diameter about 3 mm is preferred for hole drilling, as small diameter drills are more prone to breakage. It is required to dimension holes from the same surface to simplify fixturing. The fourth is about the rectangular coordinates. Rectangular coordinates are more preferable than angular coordinates to design the location of hole. We cannot use angular coordinate to make hole. So the fifth about drills is about the holes. Through holes are preferable than blind holes. It provides clearance to the tool and cheap is secondary operation like ribbing, tapping or honing, and if the drill bit always generate point holes in blind holes, as secondary operation are required. And the last and the sixth about the drills. So we recommended depth of the hole is maximum 3 times that of the diameter of the hole. If it is Maya, it creates chips clearance problem and the possibility of deviation from straightness. Special tooling, equipment, and techniques are used for deep hole drilling. For example, gun barrel bore holes can be as deep as 5 times that of the hole diameter. So now, I will explain about design features to facilitate keyways. So there is 2 about the keyways. So the first is about for generating external keyways. And milling cutter or a slotting cutter has to be used and can be done much faster compared to other processes. To suit a cutting tool, blind axial keyways should be reduced at the end. So for the second and the last about the keyways, width of keyways should be such that standard cutter can be used. If the end of keyway is reduced in such a way that it could be cut by a slotting cutter, it will improve the speed of machining keyways. For the last about the cutters or milling cutters. So there is 4 about the facility of milling cutters. So the first one is about we need to use standard cutter shapes and size. Specialized non-standard cutter are costly and difficult to manufacture, and it's hard to find it. So we have to manufacture by ourselves. For the second about the milling cutters is about product design should permit the use of the ready provided by the cutting tools. We cannot use a sharp shape at the corner, so we have to use a ready for that has no sharp at the corner that will affect at our safety and so on. So the third about the milling cutters is about allowing a bevel rather than a rounded corner for more economical machining. Bevel is about the face mill, like a shape of a rectangle, but there is another face at the product. So we don't use any rounded corner because it will affect at the machine. So the last of the milling cutter is about the end milling slot in milestone should not be deeper than the diameter of the cutter. It's because of it can be make the machine is broke or malfunctioning and affect our tool, and also it will affect our product. So that's all from me, from my public speaking. I hope what I say here, what the input that I give can bring benefit to you, and I'm sorry if the input is wrong, and you can advise and improve me. Right, thank you.